So I think we are live on YouTube now. So I would like to start the session and will request Professor Ghosh to start the session. And as I'm handing over the session over to Professor Ghosh. Please, sir.
Uh, Thank you, Anirban, and good evening, everybody. It is once again a pleasure being here and getting the opportunity to initiate the session on the different aspects of learning science. I think the topic which has been specified is something like this: that nature of science, ethics of science, scientific temper. So what I'll be doing, I'll just narrate, but before that, let me welcome all the participants. Well, we have been welcoming them and we did so on the very first day. But since I'm going to initiate this session, I, on my behalf and on behalf of TLC IIT Kharagpur, I welcome all the participants, particularly the outstation participants who have joined us during this second workshop. All these days we had a very vibrant interaction with all of them. And I am also grateful to TLC for giving me this opportunity. I particularly welcome two special colleagues of mine, Mr. Monoranjan Beda and Mr. Joydeep Pathak. I had a very useful discussion with them on 2 consecutive evenings, and it would not have happened such unless there was this program. So I hope they are there and they will also be joining me in this presentation. I have decided that today I'll be making a presentation on development of scientific temper, which is so important and which is so closely related with our scheme of things, one of which is ADI. ADI holds the center stage of this workshop, argument-driven inquiry. And argument-driven inquiry is very much based on the development of scientific temper, which is so crucial in this case. And then tomorrow, not tomorrow, I think on 7th. In fact, I have this session on 5th and 6th. Perhaps tomorrow another group will join. And on 7th and 8th, I'll be talking about nature and ethics of science. Of course, those will come by default, by way of default in today's lecture also. So I'll be talking about nature and ethics of science. And then I shall be presenting some cases of argument-driven inquiry situation, which are general, which comes from general reasoning, not direct, maybe related to the areas of science, but not directly from the subject areas of physics, chemistry, biology, and so on and so forth. So, and I think Mr. Bera and Mr. Pathak will also join me, but that will be for the next stage. So today we'll be talking on the development of scientific. So I'm going to the screen.
What did you do?
Is the screen visible?
Yes, sir.
So this is the topic, and I first would like to sensitize you by this particular clause in the Constitution of India, clause 51A, item H of the Constitution of India, where it spells out very clearly that it shall be the duty of every citizen of India to develop the scientific temper, humanism, and the spirit of inquiry and reform. Now, this is quite crucial because it is there in the Constitution of India, and not to my knowledge, there is any country in whose constitution so much of importance has been given to development of scientific temper and the spirit of inquiry. And we, as a citizen of India, should be doing justice to this particular clause of the Constitution of India. So that raises the question that do we have the attitude for doing justice to this unique feature of our Constitution? Do we really strive to do justice to this feature of Constitution? In fact, if we think of the classroom teaching learning situation, well, this may not be the case with all my fellow participants because I have been seeing and I have been observing that they have a different attitude towards teaching. Not they definitely do not promote the rote learning type of teaching learning transaction going on in school, which is very much exam oriented, and that takes away the kind of creativity which we would like to see, which we'd like to find in our students. But that is very much essential for the development of spirit of inquiry. So I have raised this question that we have the attitude for doing justice to this unique feature of our Constitution. By unique feature, I mean scientific temper, the spirit of inquiry. And as a symbol of scientific temper, I present this telescope. This is the historical telescope which was used by Galileo in the year 1609. You know that the year 2009 was observed as the International Year of Astronomy to commemorate the 400 years of Galileo's pointing this telescope towards the cosmos. Now, the year 2009, which was observed as the International Year of Astronomy, did not commemorate the 400 years of anybody's birth or any discovery. Like the year 2005 was International Year of Physics, commemorating the 5 phenomenal papers by Albert Einstein in the year of miracle 1905. But 2009 was a kind of an exception. It was not commemorating 400 years of anybody's birth or any discovery. Rather, it was commemorating 400 years of rationality. 400 years of rationality. And what is that rationality, which was very much spelled out by this gentleman, Galileo? You find Galileo in the note of Italy. So such a respect he used to get from the country. And he had taken the courage to point the telescope to the cosmos and say that seeing is believing, that I believe whatever I will see. So this is scientific temper. I'll see whatever I believe, and this he did in the face of tremendous objection from the church. In fact, the people of the church, the cardinals of the church, they used to respect Galileo a lot. They felt that he is a pride of Italy, and he has invented a device with which we can see ship from large distances, and we can make out whether Italy is under attack or not. But we have come to know that he has been using this device even after the sunset, and we should try to see that he does not do that. He should refrain himself from doing that. So see the attitude of the people, because they felt that if he points the telescope towards the cosmos, he would be seeing certain things, he would be observing certain things which may jeopardize the way they administer the people. And this is Galileo looking through the telescope, and you know the rest is history. In the year 1610, he observed the moons of Jupiter, and thereby the heliocentric concept of Copernicus that got firm footing. In fact, the day that particular book, The Revolutions of the Universe, that's the English translation of the book by Copernicus, and which was a jolt to the Ptolemaic thought. But after that book was published, it did not create much of an impact. It is said that Copernicus died almost immediately after that, so he could not take things much forward. And then it was Bruno who used Copernican concept, and he was burned to death for using the Copernican concept in the plurality of universe. So these were the two things which happened, but real impact was created by Galileo's observation of the Jupiter's moons. And we had that transition from the uh, geocentric concept of the universe to the heliocentric concept of the universe. Then this is the Halley's Comet. In fact, the last time it was seen was in 1986 in the month of April. It has a periodicity of 75 to 76 years. And earlier, there used to be a lot of superstitions going on with the appearance of comet, and it was considered to be a bad omen. Now, Halley, who could observe it and who could make out that the periodicity is 76 years or so, and the next time it would be observed will be, this is 2020. Last time it came was in 1886, so you add 76 to that, it would be sometime around 2062. So I may not be there at that time, but many of you would be there to observe the Halley's Comet. And it has a periodicity of 76 years. Now, interesting feature is related to this gentleman, whom I think you will be able to recognize. This is Mark Twain. Now, when Mark Twain was born in the year 1835, when Halley's Comet could be seen, and he was told that Halley's Comet was in the sky when Mark Twain was born, and when he became 8 to 10 years old and he started understanding things, he was told about this, and when he came to know that the periodicity is 75 to 76 years, he felt that that's a good enough lifetime span for a person, and so he wished that he die also when Halley's Comet will be in the sky, and it really happened so. He died in the year 1910. I knew a gentleman, a friend of my father, who had seen the Halley's Comet in 1910 and also in 1986. He passed away in the year 1994, and he remembers, from him I could know that it was in 1910, and at that time the Halley's Comet was very bright. The position of the tail of the comet was such that it did not require any telescope. Any person could observe it, and it was a cosmic spectacle. Now, what happened in 1986 that the tail was not really on that particular side, and it became something which has to be visible through a telescope. And I was teaching in a college at that particular time, and the
Sir,
students, yes, please.
actually, your voice is not coming very clear. So could you place your mic more nearer to you, please?
I am speaking through the mic on the laptop. I don't have a separate mic.
No, sir. So that's why I'm telling. Could you please come more closer to the laptop so that we can get a clear voice?
Is it clear now?
Yes, sir. That's clear.
Okay, that's fine. So the interesting thing happened with the telescope in the college was that uh, the students were very much interested to go and observe Halley's Comet. It was nearest to the horizon for at least 2 to 3 days, and Diamond Harbour in Kolkata was a vantage point from where you could observe. So the students somehow came to know that I'll be going there, and they all said that, sir, make it an educational tour and we will be going there. So I said that yes, we can go, but then we need a telescope. And then I started using the telescope which were available in the college laboratory. Now, the telescope which were available in the college laboratory were hardly 1 to 2 inch telescope, not even 2 inch, less than 2 inch telescope. They were good enough, but I was not very sure whether it would be able to, whether through that we'll be able to observe Halley's Comet properly. And then there was a laboratory assistant, and I think he knew much more of practical physics than many of us. And he said that, sir, do you know that in the college store there is a telescope, that is an 8-inch telescope, and that is kept there unused for a long, long time. If you can bring that out and you can use that, then it will give a very good view. Now, indeed, I ventured into the store, and somehow that gentleman helped me in getting the telescope out from the store. I cleaned the lens of the fungus, and it was excellent. Now, from that college, which is located in North Calcutta, you can, if you point the telescope towards Howrah Bridge, you can see the birds' excrete on the Howrah Bridge very clearly. That's how I'm telling about the power of the telescope. And then when it came to taking the telescope to Diamond Harbour, well, the principal objected. Principal said that it's a device, it's a property of the college, and you cannot take it outside. And I'm also not empowered to give you a permission. So then I asked him that then who is empowered to give the permission? And I was told that it's the governing body of the college who is empowered to give the permission, and the governing body cannot be made to meet so soon for just giving a permission for the telescope. So that was the situation. In fact, see, this brings out our unscientific attitude. The telescope was lying there just like a wasted item in the store, not being used. And what can be a better occasion to use the telescope than to view the Halley's Comet? And when it came to using the telescope, then so many bureaucratic norms were shown, and the telescope could not be taken. Of course, I had good linkage with Positional Astronomy Center in Kolkata, and so I tied up with them, and me and the students had very good view of the Halley's Comet. So that's a different story. But the issue of not allowing us to take the telescope, well, speaks volume about the unscientific attitude we have. That the telescope was lying rotten in the store of the college, and when it came to be used and for a very specific and important use, well, we were not allowed. The next occasion which I would like to sensitize you about is these 4 dates. Now, what is the commonality between these 4 dates? 16th February 1980, 24th October 1995, 10th August 1999, and 22nd July 2009. So these were the dates in the recent times that we had total solar eclipse over India. And among them, the viewing of the eclipse was quite fantastic on 16th February 1980 and 24th October 1995. We had very clear view. The duration, average duration over India on 16th February 1980, the track was quite long. It started from the southern part of Africa, and it went into the Arabian Sea, crossed the Arabian Sea, and entered the Indian subcontinent near Karwar, just south of Goa. And from Karwar, it almost bisected the mainland. It touched places like Raichur and Nalgonda, where we have 2 observatories. And then it touched the Konark Sun Temple, then Puri. It left the subcontinent at Puri and touched a bit of Bangladesh and ended up in Shanghai. So this was a very big track, and the average duration over India was about 2.5 minutes, which is quite long. In Puri, it was 2 minutes 16 seconds, I remember clearly. In Karwar, it was about 2 minutes 50 seconds or so, because it's the umbral cone. So the time will reduce gradually as you move from the sunrise point to the sunset point. And same with 24th October 1995, the average duration was about 60 seconds or so. And the track was almost parallel to Himalayas. It entered India through Rajasthan and was traveling parallel to Himalayas, and it touched almost near Kolkata. It touched places like Purulia, Midnapur, Diamond Harbour, and so on. And it left the Indian mainland. And it was on 24th October. This February and October, we had very clear sky. The situation was not such on August and July, but they were there. So what happened on this 16th February 1980 total solar eclipse, that there were information given through the media. At that time, of course, the electronic media was not that much active, but through the newspaper media, it was spelled out that it is going to be a very horrifying event, and you should stay indoor. Like we are being asked to stay indoor during this coronavirus. Well, we were asked to stay indoor during this total solar eclipse. That something, some disaster is going to happen, and all such things. The only correct thing which was propagated through newspaper was that don't look at the eclipse with unaided eye. And but the reason given was that some harmful rays gets generated from the sun at that particular time, which causes damage to our eyes. Now, nothing can be more unscientific than that. If harmful rays are getting generated from the sun, then those are getting generated all the time. The occasion of the moon coming between sun and earth is not going to trigger generation of harmful rays from the sun. It cannot happen like that. The only thing is that the sun rays are coming from a large distance, almost from infinite distance, and so the rays can be considered as parallel, and the eye lens, which is a convex lens, they will focus it on the cornea, which is a very sensitive device, and it can get burned. We have seen, we have done the burning of paper with the help of a magnifying glass. We used to play doing such things in our childhood. So the same thing happens here. So if you are looking at the eclipse and you are watching that phenomena of it getting obscured slowly, you may be tempted to look at it for a long duration, and that is not good for your eyes. But media could have said that there are items which can be used to observe the eclipse, and that is the overexposed X-ray plate or welder's glass with which you can very comfortably see the eclipse. And that is about the partial eclipse. And when it comes to totality, you can see with your God-gifted eye. You have to remove, in fact, the overexposed X-ray plate or the welder's glass, and these are the items of the spectacle, the solar corona, which is only visible during the total solar eclipse because the main solar disk is covered by the moon, and so you can see the solar corona. And then during the first and third contact, I beg your pardon, second and third contact, that is, second contact is the time when the sun is just getting fully covered, and third contact is the time when the sun is getting just uncovered. Then the flash of sun rays that comes out through one of the gorges of the mountains on the moon. In fact, these on the surface of the moon, as Galileo had seen, is not that smooth, and there are these gorges. In fact, on 16th February, I remember the gorges were Mare Oriental and Mare Smythe, through which the sun rays had first come out, and they appear like a diamond point of a diamond ring. It exactly looks like a diamond ring in the sky, and this is a cosmic spectacle. There are several other things. You get to see shadow bands, and I had gone to Puri, and you could see the shadow bands uh, flowing across the surface of the sea, and it was a fantastic sight. And all those things happening within those 2.5 minutes, and particularly the color of the atmosphere, that is unparalleled. You don't get to see that kind of a color in any particular time of the year or any particular time of the day. And altogether, it's a cosmic spectacle. So what we were doing, we reached Puri on 15th of February, and a day before we were trying to arrange our devices. Of course, very simple, one telescope and a device to study the variation in temperature of the atmosphere using the principle of thermoelectricity, and something to study the variation of magnetic field of Earth. And we were setting up those instruments on 15th of February. That's just at the same time as the eclipse would be happening on the subsequent day. And then we found that there were announcements through the media. There were miking through the media that, well, please don't come out on the roads. All the shops will be closed. All the restaurants will be closed. And there would be high tides, and it is not advisable to venture into the sea. And several such other announcements were being made. And then we thought that we should do a sort of an anti-campaign. So we came out in the evening, we went to the people and tried to convince them that rather than getting afraid of the eclipse, we should come out and watch the eclipse. It is a rare cosmic event, and it is going to be a cosmic spectacle. And then someone of them became very angry with us. They said that, do you know that the main food of Lord Jagannath, because that is served on at 4 times, and the main food of the day that is taken out of the kitchen around 2:30 to 3, and because that was the time coinciding with the eclipse and with the idea that foods get contaminated during eclipse. This will not be done, and you are saying that it is not an extraordinary event. You are going to say that it's an ordinary event when Jagannath Dev will remain abhukta, he will not be fed, and they were rather angry with us when we went to do this anti-campaign and we had to abandon our plans. So these are the impacts of eclipse, and in fact, particularly the biological effects, which are also very much unscientific, which gets linked with eclipse. But of course, from the next eclipse onwards, that is 24th October 1995, the media played a good role, played a really sensitive role at that time. And Vigyan Prashar and NCSTC, National Council for Science and Technology Commission, and all the state councils of science and technology, I remember, had come out with media coverage prior to the eclipse, and they had really inspired people to watch the eclipse. But still, there are doubts in the mind of the people. I'll request Mr. Pathak, you are there, na?
Yes, sir.
So I'll request you to take up at this point and tell about the effects, particularly which are related to life sciences and which causes superstitions which are unfounded and which are unscientific. So over to you, Mr. Pathak.
Thank you, sir. Our respected Chinmoy sir has already discussed about the eclipse and along with these misconceptions. Now I want to point out some misconceptions about eclipse. Humans have watched eclipses since before the dawn of written history, and during the long span of time, our scientific understanding of the physical world has grown enormously. As a consequence, many of the older ideas we had about the causes and effects of total solar eclipses have been replaced by detailed physical explanations. Nevertheless, some older ideas seem remarkably resistant to replacement by the more scientifically correct explanations. Now I emphasize on some misconceptions along with Sir's explanation. Sir already said about the total solar eclipses produce harmful rays that can cause blindness. Sir already discussed about this. Now I emphasize on eclipses will poison any food that is prepared during the event. It's also related to the false idea of harmful solar rays is that during a total solar eclipse, some kind of radiation is produced that will harm our food. If that were the case, the same radiations would harm the food in our pantry or crops in the field. The basic idea is that total solar eclipses are terrifying and their ghostly green coronae look frightening. So it is natural to want to make up fearful stories about them and look for coincidences among events around you. If someone is accidentally food poisoned with potato salad during an eclipse, some might argue that the event was related to the eclipse itself, even though hundreds of other peoples at the same location were not at all affected. Another emphasis, eclipses are harbingers of something very bad about to happen. It's also a classic case of what psychologists call confirmation bias, is that we tend to remember all the occasions when two things happen together, but forget all of the other times when they did not. This gives us a biased view of causes and effects that we remember easily, because the human brain is predisposed to looking for and remembering patterns that can be used as survival rules of thumb. Total solar eclipses are not often recorded in the historical record, but they do tend to be recorded when they coincide with other historical events. Sometimes these misconceptions also came to us that if you are pregnant, you should not watch an eclipse because it can harm your baby. This is related to the previous false idea that harmful radiations are emitted during a total solar eclipse. Although the electromagnetic radiation from the corona, seen as light, is perfectly safe, there is another form of radiation that travels to Earth from the sun. Deep in the solar interior, where nuclear fusion takes place to light the sun, particles called neutrinos are born and drift unimpeded out of the sun and into space. They also pass through the solid body of the moon during the eclipse, and a second or so later reach Earth and pass through it too. Every second, your body is pelted by trillions of these neutrinos, no matter if the sun is above or below the horizon. The only consequence is that every few minutes, a few atoms in your body are transmuted into a different isotope by absorbing a neutrino. This is an entirely harmless effect and would not harm you, or if you are pregnant, even developing fetus. Next one, solar eclipses foretell major life changes and events about to happen. This is a common interpretation found in astrological forecasts, which are themselves based upon coincidences and non-scientific beliefs in how celestial events control human behavior. A common qualification is that if the eclipse does not foretell a change in your life, it may foretell a change in that of your friends. This is a logically flawed use of confirmation bias in which you prove a cause and effect relationship by ignoring failures and only consider successful forecasts. There is nothing other than human psychology that connects eclipses with future events in your life. Another way I want to emphasize that solar eclipses are a sign of an exceptional celestial event taking place in time and space. Actually, because they can be mathematically predicted across thousands of years, solar eclipses are a reaffirmation that there applying clockwork regularity to the universe, as Sir Isaac Newton admired over 3,000 years ago. Last of all, I want to emphasize that solar eclipses, it's also heard that solar eclipses 6 months after your birthday or on your birthday are a sign of impending bad health. This is a common belief among astrologers, and once again is only supported by confirmation bias. There is no physical relationship between a total solar eclipse and your health, any more than there is a relationship between your health and a new moon. Among a random sample of people, you may find such correlations from time to time, but they are outnumbered by all the other occasions during which your health was excellent. So, last of all, according to science, I just emphasize or want to say that enjoy the beauty of eclipse. Thank you, sir.
Thank you, Mr. Pathak, for a very nice way of briefing us about the different misconceptions we have, misgivings we have about the effects of eclipse. So we go over to the next issue, that is again something celestial which happened on 10th of March 1982. It was an incident of planetary superconjunction. And planetary superconjunction are of two natures. The ideal kind of planetary superconjunction, that when all the planets along with sun, they come on the same straight line. And with the Earth at the center, then that is called the geocentric superconjunction. And with sun at center, it is called the heliocentric superconjunction. And what happened on 10th March of 1982 is that, as you can see from the diagram, that all the planets came within. Is the screen visible? Is the screen visible?
Yes, sir. Yes, sir. Yes, sir.
Is the screen visible on it?
Yes. Screen is visible.
So they all came within an angle of 109 degree. And again, there were predictions that something untoward is going to happen. I know of a person going all the way from Assam to Gujarat to meet his relatives, thinking that the end is near and some disastrous effect will be there. But again, like the total solar eclipse, it passed off quite uneventfully. And one calculation can be made. In fact, I tried to make a calculation on the effects of tides. And you know about high tides and low tides during Amavasya and Purnima, full moon and new moon. I could find out that during a planetary superconjunction, the maximum effect can be hardly 27% of what happens on a new moon or on a full moon day. And again, they were not a perfect superconjunction because if you do the vectorial addition of the forces, then the components will definitely come down to be much less than what would have been if they had all been on a straight line. And so the effect would be much less than 27%, and quite apparently and as expected, as anticipated, it went off uneventfully. And then the other event which I remember was that of Skylab debris falling on Earth. It happened in sometime in August 1979, and before it happened, it was predicted that it is going to happen on such and such day, and everybody started thinking that it would fall on his head or maybe on his house. And then I made a very crude calculation, of course, that how much this apprehension is valid and whether it is in tune with the spirit of scientific temper. Now, what is the probability of the Skylab debris hitting your house? Now, if by your house I meant an area of about 100 square meter, 10 meter by 10 meter, that's the average we can consider to be the average size of a house, and 100 square meter divided by the entire surface area of Earth. Of course, this is a little bit crude way of looking at the mathematical definition of probability, but it gives you some idea, and it comes to about 10 to the power of minus 13. Whereas if you go out on the roads, these days you're staying indoors, so it may not be a good analogy. If you go out on roads, in fact, in Delhi, about 10 to the power of 7 people will be going out on the road, and there would be about 10 cases of accidents, all of which may or may not be fatal. So that also can be used for calculation of the probability, that the probability of your getting involved in a street accident is 10 by 10 to the power of 7, which is 10 to the power of minus 6. 10 to the power of 7 times more than what would have been the probability of Skylab debris hitting your house. And so it is quite unscientific that if you are getting afraid of the Skylab debris hitting you, then you should not go out of your home. And it really happened like that. You can see the report of New York Times. I was stating August 1979. It was July 1979. You can read on the right corner of the newspaper, Skylab debris hit Australian desert, no harm reported. So that was how it happened in July 1979. Now coming to the issue of questioning, as in fact in today's session also we had been discussing a lot about answering skills and questioning skills. And question definitely has an upper hand over the answers, because think of a question. Now think of a problem. It has two facets, the question and the answer. And the answer comes later. First, it is the question, and without the question, you cannot have the answer. But we seldom try to develop this questioning skills among the learners. We keep developing answering skills because they'll have to pass examination. So that is fine. In fact, there are so many books written for developing answering skills, and they are written quite meticulously. I'm complimenting them, but at the same time, I make the comment that they don't teach or they don't inculcate questioning skills among the learners. Whereas all the eminent scientists like Albert Einstein, they used to question. This is Albert Einstein when he was about 5 years old, and then that was the time he had graduated from the nursery school to Luitpold Gymnasium, the second school which he attended and which he hated a lot. And there he used to raise many questions, like if you look at a magnetic needle, why it is always pointing in the north-south direction. Like that, he used to ask several other questions. When he was 13 years old, this is Einstein when he was 13 years old, he would ask that if I sit on a vehicle and go on increasing its speed till it acquires the speed of light, will light become standstill? We have seen this thing happening, that two trains are traveling on two parallel tracks and almost with the same speed. Then the other one appears to be stationary from your train. So he took it to the domain of light, and he said that he's sitting on a vehicle and keeps increasing its speed till it acquires the speed of light. So will that become standstill? And his teachers, who were not able to answer such questions, would complain to the principal. The principal summoned Einstein's father and told him that your son does not have a future. Now think of the assessment made by the principal about a person who later came to be known as the man of the century. You know that in the year 2000 there was an opinion poll by the Times magazine about the man of the century, and Einstein secured the highest number of votes. Next to Einstein was Franklin Roosevelt. I'm just mentioning it by the way, and third was Mahatma Gandhi. So we can take pride about that. That third was Mahatma Gandhi, and Franklin Roosevelt names become significant because these are the two gentlemen, Einstein and Roosevelt, who were involved in that famous letter, and I think the most historic letter which reached the White House, dated 2nd of August 1939, through which Einstein had made a comment about the anticipated preparation in Germany about the preparation of the atomic bomb. And this letter actually triggered the creation of the Manhattan Project. But that's a different story. But that's how Einstein and Roosevelt can be related. But the fact remains that Einstein was voted as the man of the century, and about whom the school principal had made a remark that this fellow is not going to have any future. So we don't really appreciate, or we don't really encourage students asking questions. So this is again very much unscientific. Raising question is an outcome of scientific temper. So Einstein used to ask questions. C.V. Raman had asked the question, why is the ocean blue? He didn't blindly follow the explanation given by Lord Rayleigh. Lord Rayleigh's explanation, and that came up for discussion during our session yesterday and day before. So that was about the blue of the sky, but Lord Rayleigh said that you see the reflection of the blue of the sky in the ocean and it appears blue, and that explanation was not accepted by C.V. Raman. I'll come back to C.V. Raman. I'll show you about another gentleman, Isidore Rabi, who was a Nobel laureate in physics in the year 1944, the famous nuclear physicist. Now, Rabi says in his reminiscences that when he would return home from school, his mother will ask that, have you asked a good question today? So rather than what was taught in your school today, his mother will ask that, have you asked a good question today? So that was the significance of questioning which his mother wanted to inculcate in him. Now coming to our own C.V. Raman, he had raised this question that why is the ocean blue? In fact, related to that and related to further study of it led to his phenomenal discovery of the Raman effect, and which gave the only Nobel Prize in physics in our country. So that is quite significant, and it had also a lot of implications with molecular spectroscopy as well as medical applications. And I request Mr. Monoranjan Bera. Mr. Bera, are you listening?
Yes, sir. Yes, sir.
So Mr. Monoranjan Bera will brief us about this. So I take a break and hand you over to Monoranjan Bera to speak in very simple terms about Raman effect, its application in medical sciences, and also other relevant areas of molecular spectroscopy which he may link with it. Mr. Bera, please.
Yes, sir. Yes, sir. Sir Chandrasekhar Venkatraman has a question: why the ocean is blue? Now we see in the different parts of the oceans are not a blue. To know the regions, the basic regions of the color sea is light, we have to understand about the absorption and scattering. To understand scattering of light, we have to know about during the impact of the atom with photons of light. I introduce Professor Samanto will told that some boys ask a question to C.V. Raman that Ramon explained in a way that when you play cricket, the ball coming from bowler may get more velocity or less velocity or unchanged velocity when you start by the bat or not. So when a monochromatic light like laser light or another incident on a substance liquid, it's scattered or it impact with the atoms with more frequency and then during the or less frequency or unchanged frequency that are the physics matter. I do not go to the deep sense, that is Stokes line or anti-Stokes line on another thing. These are the basic Raman effects, and the Rayleigh scattering formula will
I think due to network issue, we are not getting his voice properly, and most of the time it is coming truncated. So I would like to request Professor Ghosh that if it would be better if you may if you
yes,
could carry on.
yes, sir.
Uh,
Uh, uh,
am I
these
audible?
are the
Yes,
yes,
sir,
sir.
you are audible, but most of the time the sound of his sound is coming truncated. Uh,
Mr. Bera's sound.
yeah, that
I
is due
was
to
I,
the
I
network
was
issue.
able to get it. I was able to
Uh,
get Mr. Bera. Well, we'll
okay, sir.
what
These are
I
the basic things of Raman effects. I finish it.
so
Thank you, sir.
are you going off, Mr. Bera, right now,
Yes, sir.
or you have
I am
anything to
finished.
add? Acha, acha.
No, sir.
So coming from the domain of physicists, let us come to other eminent personalities. And here I make a comment that you need not be a scientist or a teacher or student of science to possess scientific temper. Scientific temper is an attitude towards life. Like Gautam Buddha in one of his sayings has directed all learners to be inquisitive and not to accept anything straight away because it is written in a book or might have been spelled out by a teacher. There should always be a scope for verification. So this has been spelled out by Gautam Buddha. Not to, there cannot be any high priest in science who has to be obeyed straight away. So it needs to be verified, it needs to be justified, and then only we can follow what he has said. Tagore. Now, see, we know him as a poet, as a philosopher, as a painter, as a dramatist, as a novelist, and so on and so forth. He was a multifaceted genius. And then he had written that famous volume on science, Vishwa Parichaya, inspired by Jagadish Chandra Bose, and it was, dedicated to Professor S.N. Bose. Professor S.N. Bose was 33 years younger to Rabindranath Tagore. Rabindranath Tagore was born in 1861 and Professor S.N. Bose was born in 1994. And interestingly enough, Professor Bose, Tagore did not know about Professor Bose. He only came to know about Professor Bose from Albert Einstein when he met him in the year 1930. Uh, after some conversation, Einstein, I believe, had asked that how is Junior Bose? And by listening Junior Bose, Tagore got a little bit worried that about whom he is asking. Is he ask? He's definitely not asking about J.C. Bose. Is he asking about Netaji Subhash Chandra Bose? And then, of course, Prashanta Chandra Mahalanobis was there. And then he told that Gurudev he is asking about Satyendranath Bose. And that's how he came to know about S.N. Bose. And rest, of course, as I told you, there were many interactions and Tagore had dedicated his Vishwa Parichaya to Satyendranath Bose. But I'm not talking about those higher end things. I remember of an occasion in Shantiniketan. I had gone to Ravindra Bhavan, the main museum in Shantiniketan, the main attraction of Shantiniketan, and I believe all of you must have visited that place. Now, annexed to that Ravindra Bhavan is a library, and that library contained many books, and many of those have been read by Tagore as a child or as an adolescent, and they were being digitized. And along with the books, the comments written by Tagore. And in all those books, if you pick up, almost at every page there is one comment or the other written by Tagore, and it really gives me goosebumps remembering those occasions. I picked up a book written by the then eminent teacher of science, Charuchandra Bhattacharya, and there was a chapter on electromagnet. And Tagore says, adolescent Tagore writes there that খুব জটিল বিষয় না দেখলে বোঝার উপায় নেই খুব জটিল বিষয় না দেখলে বোঝার উপায় নেই So this is really scientific temper, and so you don't need to be a scientist to have a scientific temper, and that gets very vividly revealed through the observations penned down by Tagore in that book. Swami Vivekananda, I am not talking about any religious thought or any religious belief, but during his quest for God, when he was desperate and he was meeting all the sages of his age, he went to Maharshi Devendranath Thakur also. And every time he was asking a very direct question. And since I'm relating this to the issue of questioning, I'm asking you to appreciate that. Please appreciate the directness of the question. Have you seen God? Apni ki ishwar dekhechen? Have you seen God? So there is no indirect approach there. It's a very, very direct approach, and he asks the question that have you seen God? So this questioning skills is extremely important, as also in the case of Mahatma Gandhi. He performed his experiments not by picking up acids and alkalis from the shelves of a chemistry laboratory, but he did pick them up from the lives of human beings, and he performed his experiments with truth. So you need not be a scientist or a student or teacher or a researcher in science to possess scientific temper. Scientific temper is an attitude towards life. At this stage, I'll once again request Mr. Bera that if you have any idea about talking about superstitions, would you like to speak about superstitions and how we get swayed by superstitions in unscientific way? Mr. Bera, are you there?
Sir, I am present here.
Now your voice is very
but
clear.
Due to I am clear.
Very clear, very clear.
Yes. Scientific thinking is the basic idea to remove the superstitious ideas or any other matters incident which are happen in our society. I am a teacher of a school that belongs to matters.
So, Dr. Ghosh, can you hear the voice of? Hello.
No, initially I could, but now I am not able to hear.
That's the problem I was
Hello.
talking about. He is losing his. He's on a very lower bandwidth, I think, and that's why the voice getting truncated and
Yes, sir.
Okay.
Yes, sir. So I request Sir Chinmay sir to continue this session.
Okay. Now, talking about the situation in a science laboratory, in fact, this was mentioned by Anirban yesterday also, that what we teach in the science laboratory, we normally ask the learners to perform routine tasks. And I have been told about the examination system, particularly in the school science laboratory, and the students don't pay much attention to the laboratory work, and they feel, and in fact more than the students, it's the guardians who feel that it's a wastage of time. And if they know about a good teacher in physics, a good teacher in science, that they know from the theoretical exposition of the teacher, not about his practical capabilities. There is no role model, generally no role model like our Subhash Babu. Professor Samantu is a role model. I hope I'm not embarrassing him by saying this. He's a role model in the area of experimental physics. And the array and the number of plethora of experiments which he has designed with inexpensive devices, it's remarkable. But then there are very few role models in experimental science, in experimental physics. That is because of our attitude towards the laboratory work. And one particular example will also justify my point. In fact, the students are supposed to use a laboratory notebook. And by laboratory notebook, Anirban had made a reference about this. By laboratory notebook, we mean the notebook which has to be used in the laboratory. That is, you are supposed to put your records there inside the laboratory. And that laboratory notebook has to be kept very carefully, has to be kept very neat and clean. But then, in order to keep it neat and clean, we should not be making compromise with scientific honesty. But that's what we exactly do. It is not used in the laboratory. In the laboratory, what we do, we use a rough notebook. And from the rough notebook, we copy things in the fair notebook, which is the laboratory notebook, and we do it at our home. Now, a famous teacher of practical physics, GL square, SQUIRE, now he has made this comment that copying is a wastage of time. There is every possibility of committing mistakes while copying, and there is an irresistible temptation of being selected. Like you see, you're performing an experiment with Ohm's law, and I versus V curve, we have taken 10 points, out of which 5 falls on a straight line passing through the origin, and another 5 does not. And you remove those 5 points which are not coming on the straight line. So in the process, what you have done, you have ignored the observations made by your own eyes. You have considered those data to be inadmissible without giving any reason, rhyme or reason behind it, which is very, very unscientific. So you can curb this habit of students by asking them to write in the laboratory notebook in the laboratory itself. In fact, you're not making the notebook untidy. If something, suppose, comes out and which you don't want to present, you do a line through that. That doesn't make the laboratory notebook very much untidy. But using 2 notebooks is a very, very unscientific approach towards the laboratory work. Coming to an experience which I had with the students in a laboratory. In fact, one student has observed, that was a higher secondary practical class, I remember, and in the college we had to take practicals, and my partner was a very senior teacher. In fact, every laboratory class was being handled by 2 teachers. And one student came out with the value of specific gravity of copper sulfate solution to be 32.7. So when he brought his work to my fellow teacher, he was very angry and he was not at all willing to see what he has done. And he said that, just go and repeat. I'm not willing to see what we have done. But he was very persuasive that, sir, please tell me what mistake I have committed. And then by seeing him pleading time and again, I requested my senior teacher that let us see what he has done. And quite reluctantly, he said, Tumi tale dekho, you see what he has done. I don't have any interest and they are all bogus. And like that, he made a comment. Now, what you can see on the screen is the formula for determination of specific gravity. SC is the corrected specific gravity is equal to SO, that is the observed specific gravity, into rho T, that is the density of water at T degree centigrade. T degree centigrade is the room temperature. And I asked the student that if you say that the specific gravity is 32.7, and perhaps it was an experiment with hydrostatic balance, so where he had taken the solution in a beaker, and I said that had that beaker got mercury, do you know what's the specific gravity of mercury? And he said that it's 13.6, he knows. So then I said that had it been mercury, and you feel that your copper sulfate solution is almost 2.5 times heavier than what the mercury would have been. He said, no, I know that mercury would have been very heavy. So then I said that you should have applied your mind, there is some mistake. But then again he pleaded that, sir, I cannot find out what mistake I have committed. And when I saw the book he was following, now the same relation was written, but there was a printing mistake. This rho T, the T did not come as a suffix, but it appeared just after rho, appearing to be rho multiplied by T. So his S observed was about 1.09, which is normally the value of specific gravity of copper sulfate solution. Density of water is roughly 1 gram per cc, and T degree centigrade T was about 30, and 30 into 1.09 comes to be 32.7. Now, he was not a good student because this particular relation, he should have been able to find out that or make out that this relation is not valid because it is dimensionally inadmissible. The left hand side is dimensionless, whereas the right hand side has dimension of whatnot, density into temperature, and which is definitely something not acceptable. And he should have observed that, he should have been able to find out that. So he was not a good student, but I cannot help but appreciate his scientific honesty. And I feel that if such students are nurtured, then we'll be able to groom very good experimental scientists, which is quite a rare commodity these days. And another experience to remember is about the students of nursing doing this experiment. Well, being at the Indira Gandhi National Open University, we have multiple number of programs, and a very coveted program is BSc Nursing. In fact, every center which has to be recognized by the Nursing Council of India can only admit 30 students, and there is a very tough and stringent competition for getting into this program. For 30 seats, about there would be more than 500 applications, and they have to undergo several areas of practicals in going through this nursing program, and one of them is on applied sciences. And applied sciences is again divided into 5 areas: physics, chemistry, mathematics, I beg your pardon, physics, chemistry, botany, zoology, and physiology. Now, in physics, they had a practical on the verification of parallelogram law of forces. And Indira Gandhi National Open University, we do not have our own laboratories, so we had to hire infrastructure. And we had gone to one of the centers in Kolkata for providing this facility to the students. And that particular college, they did have a physics laboratory, but they didn't have the setup of this experiment. But then it was spelled out that we cannot do this experiment because we don't have the setup. But what I did, I could pick up some corks and a string with the help of a very senior teacher. Both of us applied our mind to use the corks, the string, and weights from weight boxes to do the setup. And I was about 30 years younger at that time, and naturally I was feeling quite elated that they were just now saying that they will not be able to set up the experiment, but in no time we have been able to set up the experiment, and now it is ready, they can perform the experiment. And once I was sort of basking in this pseudo glory. I should say it is pseudo glory. It was not a glory at all when you get to know what happened just a little while later. When we were doing this setup, I heard the nursing students whispering at my back, saying that this is the arrangement which we use for giving traction to the orthopedic patients. So this is the arrangement which we use. This is the application of this arrangement we take up when we give traction to an orthopedic patient. So this was remarkable. In fact, I never felt so ashamed in life that I am a person who know the theory of parallelogram law of forces. I know about the experimental setup, but I don't know about its application. Whereas these girls who have not studied science in their schools, they have not studied science in their schools, but they know the application. So they are in a way a step ahead of me. So science triumphs when its impact can be felt by the common man. You can see the common man of R.K. Lakshman on the screen. So when it is felt by the common man, then the society gets impacted by science and technology. I think I'll take a break here again and will request Mr. Pathak to tell about the application. Another experiment which I had seen during this time was that of Boyle's law. Among several other experiments, they were asked to verify the Boyle's law, and that is related to determination of the blood pressure, the systolic and the diastolic blood pressure, and several such other biological applications can be thought of. And so I felt that we'll give the cue to Mr. Pathak to add on this. Mr. Pathak, are you there?
Yes, sir.
Please.
Okay, sir. Thank you, sir. I'm trying to give some view. Uh, in case of blood pressure measurement, Boyle's law also applicable. Actually, we know that systolic blood pressure is the highest pressure during systole, whereas the diastolic blood pressure is the lowest pressure during diastole. During systole, normally the volume of the heart decreases, and in diastolic condition, its reverse condition occur. So normally we found that the systolic pressure is about 120 millimeter mercury, and the diastolic pressure is about 80 millimeter mercury. If we study then that how measurement of blood pressure is occurred by sphygmomanometer, then we see that the radial pulse of the arm of the patient is felt after rubbing the cuff. While feeling the pulse, the cuff pressure is gradually increased by the hand pump, and at one point the pulse disappears. The pressure is raised further through another 20 millimeter of mercury. Now the pressure is gradually released, normally in 2 millimeter per second. The point where the pulse reappears is noted. It gives the systolic pressure. It is called palpatory method. The air is then completely released. In the next step, normally the pressure is raised again up to 20 millimeter more than the systolic pressure obtained by palpatory method. The stethoscope bell is placed over the brachial artery distal to the cuff, and the pressure is gradually decreased. At one point, sound is heard which gives the systolic pressure. The sound continues for some distance and then disappears, which is taken as diastolic pressure. This method is called auscultatory method. The range from the systolic pressure to the diastolic pressure is divided into 4 phases on the basis of 4 types of sounds heard. These sounds are called Korotkov sound. I'm not emphasis on the sounds because it will be more deep in biology. Now I want to emphasize on the mechanism of the process. Actually, the mechanism of the process is very simple. When the cuff pressure is higher than the pressure in the brachial artery, no pulse is felt as the artery is completely occluded. Neither any sound is heard due to lack of blood flow. When the cuff pressure is just below the systolic pressure, blood flows, but only at the height of the systole and is taken as systolic pressure. This is indicated by appearance of the pulse or tap sound. All these sounds are produced due to turbulence caused in the blood flowing through the brachial artery, which is narrowed by the cuff pressure. When the cuff pressure is just below the diastolic pressure, the arterial lumen becomes normal and the flow becomes streamlined, that is silent. We should remember that for this reason, by placing stethoscope over a normal artery, no sound can be heard as the flow is streamlined. I also correlate Boyle's law with the another places of another streams, another aspect of biology. Boyle's law also function in a syringe. In case of syringe, the volume of a fixed amount of gas is increased by drawing the handle back, thereby lessening the pressure. The blood in a vein has higher pressure than the gas in the syringe, so it flows into the syringe, equalizing the pressure differential. Same too, deep sea fish die when they are brought from the depth to the surface. The pressure decreases dramatically as they are raised, increasing the volume of gases in their blood and swim bladder also. The same principle applies to diver when they get the bends. If a diver returns to the surface too quickly, dissolved gases in the blood expand and form bubbles, which can get stuck in his or her capillaries and organs. Boyle's law can be used to describe the effects of altitude on gases in closed cavities within the body and to calculate the total intrathoracic gas volume by body plethysmography. As altitude increases, ambient pressure decreases, and therefore, by Boyle's law, volume expansion occurs in enclosed spaces. Last of all, if you blow bubbles underwater, they expand as they rise to the surface. One theory about why ships disappear in the Bermuda Triangle relates to Boyle's law. I think so. Gases released from the sea floor rise and expand so much that they essentially become a gigantic bubble by the time they reach the surface. So small boats fall into the holes and are engulfed by the sea. These are my explanation or correlation of Boyle's law to the different parts of nature. Thank you, sir. It's now to you, sir.
We'll definitely would like to know more about this Bermuda Triangle disappearance from you. Maybe at a later stage if time permits. I'll quickly go through the next part of the slides. In fact, again, another experience. This happened in a primary school, and I had to visit that for some reason. And there, the mathematics teacher was taking a class on subtraction. And exactly this was the example she had taken up. 18 was to be subtracted from 45. And she told that 8 cannot be subtracted from 5 because 8 is more than 5. Now, I could make out that in the previous class, all those kinds of subtraction was taught, where, of course, the quantity to be subtracted is less than the quantity from which it has to be subtracted. And so that part of subtraction they knew. And then she said that since 8 is more than 5, so we have to borrow 1 from 45 and make 5 15 so that we can subtract. And 15 minus 8 is 7, so we write 7, but we have to remember that we have borrowed 1 from 4. So 4 is no longer 4, it has become 3. And so rather than subtracting 1 from 4, we have to subtract 1 from 3, and the tens place is 2, and so the result is 27. So this explanation is very much in order, and we have done this sort of thing. But one girl, now interestingly, in that primary school, and that tells about the veins of our education system, that the same teacher was teaching all the classes, the same teacher was taking language class, science class, mathematics class, and so on and so forth, and maybe also looking after midday meal. So this is an unfortunate situation. And she had taken their Bengali class a little while ago. And the girl remembered what she had said in the Bengali class as the sum and substance of a poem. And where she said that in Bangla, dhar kora onnay, that is, it is unfair to take loan. But in the mathematics class, when she said that you have to take loan from 4, you have to take 1 loan from 4 and make 5 15. The girl reacted by saying that in the previous class you told us that taking loan is a sin. So that was a lesson, an eye-opener for me. And believe me, after that, I have never used my credit card. I have been using debit card, definitely. But after that, I have never used my credit card. So don't underestimate your students. My issue was that of questioning. Please please keep encouraging the students to ask questions and don't underestimate them. And so where do we go from here? In fact, I suggest that let there be appreciation courses in the curriculum about scientific temper. Let there be foundation courses in science and technology, which is to be read by students of arts and commerce. Let there be foundation courses in science and technology to be read by students of arts and commerce. And let there be projects on the inculcation of scientific temper. Because science and technology are secular. Nothing can be more secular than science and technology, and we are driven by them. And we are the drivers of change. And since we are the drivers of change, I would request you to focus on the word secular. In fact, secularism is very much scientific, and you know the kind of debate, the kind of controversies, kind of quarrel those are on with secularity. But see, if you go back to the year 2011 when we had won the Cricket World Cup, well, Dhoni was the captain. He was a Hindu, and the main strike bowlers Zahir Khan and Harbhajan Singh were Muslim and Sikh, and all playing under a Christian coach, Gary Custon. So my message is, if we can play together, we can also stay together. If we can play together, we can also stay together. So with this, I think I conclude for the time being about, because this particular slide can be the depiction of scientific temper, the depiction of secularism. And I started with the concept of telescope, telling it to be the symbol of scientific temper. And the outcome of scientific temper is the secular thought in our mind. And so with that note, I conclude, and I would request if Mr. Pathak or Mr. Bera has to add something on it, or we go over to Anirban to conduct the remaining part of the program. Thank you.
Thank you, sir, for such a good lesson and such a good lecture. And with taking cue from your narration, I would like to mention another example in our human body, which is related to the Boyle's law. Uh, as you know, and most of you have the experience, when you attain a sudden height or altitude, when you gain altitude suddenly, that means when you start to go on high hills, and suddenly you start to gain higher altitude. What happened? Everybody of you, I think, feels this thing, that you start your hello, I'm audible. Hello, hello.
Yes, sir, you are
Yes, sir,
audible.
you are audible.
Okay. So what happened, uh, did you ever noticed something happen in our ear at higher altitude? Hello.
Yes, sir. Sometimes we get a tick sound in the ear and it get blocked. And
Yeah.
again, while coming down, again another tick sound and it get open suddenly.
Yeah, our ear get blocked. That is also due to the same thing that Boyle's law sir told. Actually, what happened, there is a eustachian tube which connects our connected at our middle ear, and it connects our middle ear to the inner mouth part. So this tube, actually, what in this tube, the air remain uh, locked within this tube at certain pressure, which is our normal atmospheric pressure, and that is how our inner ear balance the pressure with the inner pressure with the external atmospheric pressure. And what happens when we get suddenly we get height, the external air pressure becomes low all of a sudden, but the inner pressure remains same. And due to the lowering of external pressure, uh, inner ear get expanded and our ear get blocked. And again, when you down your altitude, your external pressure get rise and the thing reverse. So this is another one example.
In fact, I remember, in fact, during air travel, they used to give this
Yes, sir.
lodgings,
Yeah.
and they used to give the cotton wool. But from
Yeah.
some stage, they had stopped this practice, and this feeling in ear causes some kind of discomfort also, and that was getting minimized by use of the cotton and the chewing of lozenges. Now, why it was stopped? Any idea?
I don't know why they stopped this practice, but in when we use cotton plug, what happens? This cotton plug locks some air within it and put extra pressure on the middle layer, and that is how it is balancing the pressure difference.
Right, right. That I understand.
So these are the examples that we can have, that we can correlate. Actually, that I have told earlier also, no subject is a separate thing. Everything is connected to each other. Science is in nature, and nature never separates it as a subject, different subjects. So there is no any borderline. So always we have to think connecting all the knowledge that we have and analyze it. After that, we can conclude properly. Otherwise, we cannot get a clear. Otherwise, we cannot have a proper clarification of the things what is happening around us. So, as a teacher, as a student of science, we always have should have an open mind and should correlate the things as it is in nature, not as putting boundary in between them of physics, chemistry, and biology. So these are the part of scientific temper, I think, that Professor Ghosh also tried to say, and that was a very good lecture. And now I would like the participant, if you have any question, you can ask to Professor Ghosh. So I think you don't have anything to ask, or if you have any suggestion, you can provide also. So that will be great if we could have a both way direction interaction. So both way interaction will be appreciated always. So is anyone to ask or suggest anything? Okay, let us move forward. If you have
I
any
like to have
question.
it. I like to
Yes,
make
sir.
certain comments. Anirban,
Yes, sir. Please.
I like to make certain comments. This time we are not only speaking about interdisciplinary sciences, but we are speaking that interdisciplinary knowledge actually. You see, Professor Ghosh started with Constitution of India, and he has actually driven by the constitutional aspect related to scientific temper, humanism and inquiry, and our scientific discourses. So this is really very much exciting to know. But one thing I like to ask from our learned teachers, that this constitutional aspect is actually very much written on the first pages of the books taught in the secondary classes in the schools. In fact, the first paragraph of the preamble is actually published in the first page of all the books. It is sometimes here in West Bengal, it is written in English as well as in Bengali also, in other Hindi and local language and so many things. But I have also noticed, I have asked the students that have you rather read this passage? But there was an emphatical no. Even the teachers also used to tell, no, they don't bother, did not bother to go through this passage. So this is, I maybe I am wrong. I want to know from the learned teachers, what are their experiences in their own schools? Because it is, this time we are actually meeting a cross-section of teachers from different parts of the country. So I have an interest to know how do the things, those are actually published in the textbooks. Will you please make certain comments, our learned teachers? Am I audible, sir? Hello?
Yes, yes, sir.
Very
Clearly.
much audible, very much audible.
Oh, okay, okay.
Am I audible?
Yes, sir.
Yes, yes.
Sir, I think you have rightly pointed out that it's a sorry state of things that the preamble part, which is embedded in every textbook of any boards, they are not highlighted in that way by the respective subject teachers. I mean, not everyone, but in general, it is not highlighted. That is a truth in practical sense of the term. So I don't know if the education system highlights it, or some questions which may be value-based questions or something like that. Those are incorporated in almost every boards, state boards. That might change the situation a bit. Thank you.
Thank you, Mr. Chandru. Am I audible?
Yes, yes, you're audible.
So thank you for your observation. What you have said is very true. Now, there is actually nothing can be taught by force. Nothing can be taught by force, but there are certain things for which some effort has to be made. Now, NCRT, who are the custodian of these books, they have given that preamble in every textbook. Now, it is the duty of the schools and maybe also the teachers to bring home this point to the students that constitution is something which all of us, and the basic tenets of constitution, and particularly the article which gives us the right to education, the right to life, the right to protection of life, the right to food security, the article numbers. These are certain things which one must know. I'm not telling them to know all the articles and the contents of the entire book on the Constitution of India. But then the Constitution of India is the set of rules on which we are governed. And the school has some responsibility, and school has to perform this responsibility through the teachers to bring home this point to the students. And one of the observations which I would like to make, and which I feel a little bit uncomfortable about, is that whenever there is a celebration of Independence Day and the Republic Day at the schools, now, in many cases, I think Independence Day is observed on the same day, which it should be. But in many cases, it is not. And Independence Day is declared as a holiday. Something happens, I think, on a day prior to the Independence Day. Why it should happen like that? The student should get to know what is the importance of this particular day, what is the importance of the hard-earned freedom. And the same thing perhaps does not happen with the Republic Day. Republic Day is not observed, and even if it's observed, the flag is hoisted and we tell about the glories and the sacrifices made, the supreme sacrifices made by the people. That is fine. But the same sort of speeches and the same sort of performances are made on the Republic Day as well as on the Independence Day. Now, we should remember our martyrs who had laid down their life, who had made supreme sacrifice for this hard-earned freedom, no doubt about it. But the Independence Day and the Republic Day has two different roles. And on this Republic Day, you get an opportunity to tell the students about the Constitution. That we have got something on 26 January 1950 by way of which we have to rule. We get ruled by us. When the British left us, they left us in a situation of slavery. And not only that, it was a situation where we were unable to move a step ahead because we had no rules to govern ourselves. And now here we have a set of rules which is prepared by ourselves, the Constituent Assembly. And that has to be hit hard on the mind of the students so that it gets impregnated in their mind. And 26th January is the ideal day. And my worry is about, or my feel of discomfort is about that we don't make any distinction whenever, even if we observe, first on the first place, we don't observe functions which we should do religiously on these 2 days. And we should make the student realize the difference between these two. The same sort of songs, the same "Ae Mere Watan Ke Logo" will be sung on the Independence Day as well as on 26th January. There is no harm in doing that. We should remember our martyrs. But along with that, on 26th January, we should give importance to the Constitution. And it is very rare that our Constitution has given a cue for scientific temper and spirit of inquiry. That is remarkable feature of our Constitution, which the students must know. So this is one observation I thought I should make.
Devmalla Sen was raising his hand. I think you want to say something. So please carry on.
Sir, I am a teacher from ICSC board. In ICSC board syllabus, the history is divided into two parts. One is civics and another is history. And in the civics part, a large part of constitution and the duties of the prime minister and the architecture of the, I think that civics is taught.
No, actually, we are not. We don't want to focus on particular subject as civics as subject. Actually, we want to say that every book is there is a in every book where the preamble part of the Constitution has been printed. So, do we do the justice to this? Do we explain it to our students in our physics class, in our chemistry class, in our biology class? That is the point we want to raise. The part of the preamble that has been embedded in every book, and it has been done with a purpose. And do we serve the purpose? Actually, what happens every time we think that there will be there is a Pandora's box, there will be a Pandora box that will get open suddenly, and our student will start to think logically. They will know their right. They will act on their right. Everything will be miraculous. But unfortunately, that is not going to happen. We have to make our future. We have to prepare our future as we think. So that is the basic things that Professor Ghosh also and Professor Samant also try to say, that we should bring the practice in reality, that our students should know what it means for what are the what our preamble said. And because without making a broader mind, uh, without letting them know what are their what should be the logical practice, uh, actually these made the what Professor Ghosh was saying, that that will bring the scientific temperament that you are talking about. Scientific temperament, logical thinking, inquiry based thinking, everything will come after when we start practicing, when we start making the mind more broad. I think that was the focus point. Yes, Subroto Chandra raising the hand, and Snehal Chaudhary. So I would like to call Subroto Chandra first, and then Snehal Chaudhary. Yes.
Okay, thank you, Dr. Mukherjee. Just a few words. Maybe it is a bit out of the topic or may not. Just I wish to mention that since scientific temperament is the topic here, so what we do now, rationality has become synonymous with science since the last century at least. So science is basically an authority on rationality. Everywhere, wherever there is a confusion, we bring science to put an end to the speculations. the scientific outlook, which really matters, as Professor Ghosh has also mentioned, that scientific this scientific outlook, it actually crosses all the barriers of subjects. It is irrespective of any subject. A person is supposed to have a scientific outlook towards the things he or she is studying or investigating, whatsoever the subject. Now, in doing so, I wish to mention a few points that, like,
Yeah, sure.
am I audible?
Yes, yes.
Okay. So, in certain discourses of science outright denies certain aspects. Like, for example, science denies any effect of homeopathy based on the research that in very high dilutions of homeopathic doses, even there is no molecule left, but still it is medicine in the homeopathic term. But mainstream science disregards it and calls it a placebo. Now, but we know that when this medicine is applied, it acts. Out of 10 patients, maybe 8 are cured. And now, since the theory behind the homeopathy is not yet proven, so science tries to disprove it or disregard that aspect. But experimentally, it has been shown that it has its own effect. Since it is not backed by a theory, so it is disregarded. Now, is this aspect of science not a bit unscientific? Just it occurred to my mind, so I
Okay,
raised
okay.
the question.
We got your point. We will
Okay,
discuss
okay,
on
okay.
that. And
Thank
next,
you. Please.
I would like to call Snehal Chaudhary.
Hello, sir.
Yes.
First of all, I would like to thank Professor Ghosh for such a wonderful lecture. Uh, and also the point which was raised by Professor Samantha, that in our preamble we have uh, in the science textbooks we have the first page where it is mentioned about the scientific attitude. And what I think is that when you are talking about science or the scientific temperament, it is not that the suddenly the children will be inculcated with the scientific temperament. So it is a slow and steady process. So also it has got a lot of factors on which it is going to depend. The home environment is there or the culture is there. So all these things are also going to uh, affect the process of development of scientific temperament. So as a teacher, what we can do is that, as was discussed in previously also, that the uh, talking about the science, its interconnections with other different subjects, and how you are able to explain the things logically. So if I think as a teacher, if we are able to do these things with our students, that will really help for the development of the scientific temperament. And also, as Professor Ghosh has pointed out, the questioning is a very important part. So we should not miss that particular point, that let our students ask a lot of questions. And that is how maybe when they will grow up, they will have the scientific temperament
Yes.
among them.
Yes. Yes.
Thank you, sir.
Yes.
I
This is
like to give
crucial
one
point.
point. Hello,
Yes, sir.
am I
Yes, sir.
audible?
Yes. Yes. Yes.
Acha. Anirban has made a pertinent point that what is the logic behind including this preamble in the textbooks, and NCT has done it. NCT and many other states board also has done it, have done it. So they have certainly a definite logic that our students, even at the very low age, should be introduced to the basic ideas of constitution and what does it contain. So, but in fact, the things are not going to happen according to the decision of the policymakers in this regard. So, I think as teachers, we have something to do. Either we can tell the authorities it is useless. It is useless. At least in that case, you remove them from the book so that at least some money can be saved. Number one, or teachers can take some initiative. Let us, as Professor Ghosh has really elaborated, that we have got at least 2 days, 15th August and 26th January, when the school is actually supposed to deliberate on the explanation on the importance of those days. I think whatever done is good, certainly, but over and above, we can deal with this aspect that let us read the paragraphs and try to understand the meaning of this. Is it not possible to introduce these things in the schools? At least the teachers who are assembled here at least can propagate this idea that we can do this at least on those 2 days. Because the teachers are coming, students are coming, they're celebrating. So I think in each classroom, one lecture can be dedicated at least for those days for the students. Is it not possible? I think then it really has got some meaning to include this, the inclusion of this preamble part in the textbooks. That is my observation.
Okay, now I am going to take the point raised by Subrata Chandra. So, is anyone there who will take the lead to discuss on the topic? Professor Ghosh, do you have anything to say on that topic?
Sir, your voice is too faint, can't hear.
Okay, so I am going to lead with the topic that raised by Subrata Chandra. So I am asking Professor Ghosh, do you have anything to say on that topic?
What Mr. Chandra, am I audible?
Yes.
What Mr. Chandra has said is very right. Now, but I would have said in my talk on nature of science that though we depend on direct evidence, in fact, he was referring to lack of direct evidence about the success of homeopathy, if I've understood him correctly. But empiricism and conjecturism, they are also two elements of scientific endeavor, and they have their places in science. So, what you can tell about homeopathy is that it is a kind of an empirical science.
And I think until we cannot prove all the things scientifically, we also should not outrightly deny it, but we can think on it, and lots of scientists are working on it to prove the pathway how it is working, but still they didn't get such success. Maybe someday they will get, and then there will be some proof behind it. Though I can remember one paper was published in Nature regarding the issue, and that was and the author described a theory, that is molecular shadow theory. I think you can get the paper if you search in Nature. The molecular shadow, what Subrata Chandra pointed out, that
Yeah,
in that
memory of molecules theory, right?
yeah,
Okay,
and
okay, yes.
uh,
I've read it.
that yeah, so that was on paper, I think I saw in the Nature. So that are some steps are being taken, they are under investigation. Might be someday we can prove it or may not.
In fact, if I recall correctly, that paper had a number of citations.
Yeah, that was a great paper.
And at some stage, the nature authorities had to tell that they will not accept any further reactions on that paper. I remember.
Yes, that started a big argument on, lots of people argued on that paper, and whenever there is an argument, there is a way.
So, yeah, Mr. Chandra, how do you react to my observation of that science being empirical and empiricism has a place in science, like conjecturism also has a place in science.
Yes, sir. Definitely. That is the, I think, that is the most viable explanation that you have put forward. That is so. And but the amount of weightage which is being given to empiricism, uh, according to my opinion, I think maybe it is a bit lesser because so many things are unknown till date. So since skepticism is very much a part of science, so I mean, just in the case that like metaphysics was altogether denounced at a point of time earlier, but later it was shown that metaphysics had many elements which were really interesting and which led to modern science. I mean, questioning the points of metaphysics only brought the modern science into the current scenario. So you were absolutely right, I think, as you said, that it is an empirical science, definitely. But I mean, getting more skeptic about the things that we draw conclusions from modern science, uh, we can bring it into the culture of our students. That's it. I think you just mentioned it correctly only. Thank you.
And I do agree with you. Actually, the thought process varies man to man. If you have an open mind, then I think we should not deny something that we don't, that we have right now, that we are unable to prove. Because someday we can prove it. But if you do not have any proof right now, you should not deny saying that is this all are bogus, as you mentioned in case of metaphysics some at some time. So so it would be very logical if we say that right now we don't have much proof, but work is going on, and see what may happen.
Actually,
Yes, absolutely. Thank you.
actually, what Professor Ghosh was telling, that empiricism, you see, that really empiricism has very great role, particularly in terms of, you see, homeopathy. Really, you don't know what is happening because when the dilution is so much, then if not a fraction of a molecule is present there. That is true. But the point is again, as Chandra also suggested, that in fact observed that out of 10 patients, 80 patients cured out of homeopathy. And that is part of the experience of all of us. Some people will say that out of 10 patients, 10 will cure without any medicine. That is also evidently clear sometimes. So I think our observation is not against homeopathy. It is I have to that emphasize that thing. Our observation is not against as such against homeopathy, but we don't have like allopathy or other system of medicine. We don't have any scientific view also. So this thing we have to accept, and I think we can expect that sometimes some theory will be there, some theoretical modeling will be there for the homeopathy system. That's true.
And actually only you can accept this kind of thing when you have a broad mind to accept such things.
And not only broad mind, as we are getting the effects, you may not believe in homeopathy, but when you are in trouble and if you don't have other system of medicine to approach, then if you approach some homeopathy medicine and you will get that you are getting some relief. That you have
that
to
means
admit that yes, that is the
that
point.
means you are logical, sir. That means you are logical. You are using your logic and your mind to accept whether it is to accept or not. You are logical. That's why you are telling in this way, and that is our point. We have to make
No,
our student logical.
again, it is really illogical when we see that in the medicine there is nothing in fact. Nothing in fact. When the dilution is 1 m or like that, then even not a fraction of molecule is there. Actually,
Ye-
the simple arithmetic will tell us. That I'm
yes.
telling. And again, we have seen the effect of that medicine. So naturally, on the one, because it has got some effect that is visible, that is observable, so we have to accept it.
Yes, sir. That is. I try to say that you are judging it logically, as you are saying that we are seeing some example that
Logic actually does not support me taking that decision. Because you see, logic is what? Because we are now in the realm of explaining everything on the basis of atoms and molecules. So molecular theory is not helping us to explain the homeopathy system. Only observations, only its effects on our systems. So logic does not help here, you see. But if you see that it is the logic that experiment is supreme, then then you are correct.
But you are getting clue that few patients are being cured. Actually, what happened few years ago, we are not aware of the dark particle also. So in that point of time, it was illogical to think of such material. Isn't it, sir? But scientists kept on going by gathering some such logics and by testifying
I should say
it.
that you see that Stephen Hawking is has written the book which is still the bestseller, but he was not given the Nobel Prize because his theory was not did not get any experimental support. So that is the point, because people naturally scientific community will think in that way only. So
Yes,
as
sir.
homeopath medicine has got experimental support, but it does not have any theoretical model behind. And naturally, people do not get that much excited to accept homeopathy. But they have no other alternative also without other than accepting.
So these are the fallacy, I think.
No fallacy. Science actually works in that way. I am telling you. So from the history of liver system, you see. Now we explain everything, every liver system based on the principle of equal moment. Okay, but this has come only after Newton, you see. Before that, liver actually functioned from ancient times. Liver worked very well. We developed technology on the basis of liver system, liver principles. Okay, but we can explain only the things after Newton, not before Newton. So scientific expansion of the liver system actually was held by Newton's announcement of his 3 laws. So science actually works in that way. When we get some experimental evidence, we cannot deny it. Suppose in case of electromagnetism, production of electricity, it was actually done by Faraday's law, Faraday's experiments on electromagnetic induction that we discussed earlier. But and after Faraday's discovery, actually technology was to improve it to get electricity. But not even the theory was not that much even then. Even now, we do not understand many things about transportation of electricity, use of electricity in the technology series.
So that means we should grow our student with such analytical mind.
Analytical mind, that is the important. That is important. We should not be very vague. So homeopathy is not bad, but homeopathy does not support it.
Till date, it is not supported by any. Yes. So we can conclude.
So our children should
by
be very much open-minded. Yes. Their mind should not be closed.
That is the thing I wanted to point out.
As we are telling that they should be encouraged to ask questions. The child should tell. In Bengali class, you have told that lending is very bad, but in mathematics class, you are telling that you have to lend it for computation. So we should have some rather compromise.
So I think it was a very enriching session.
But again, in the realm of constitutional rather applications in science teaching, actually we are doing nothing. We are telling that science is very secular. We are telling anything, but in practice we are not doing it. Even if you see when in IIT, when a new instrument is coming, that people goes to rather worship Vishwakarma. That is the fact. When one celebrated professor wants to submit his thesis for his student, he will tell you find an auspicious day. That is what's happening. Maybe somebody will call. Yes, he needs some mental encouragement, mental stability, mental peace. Yes, that is also true.
So we are reaching at the fag end of the program, and I think now we can conclude with the due permission of our respected mentors, Professor Ghosh and Professor Samanta. So may I conclude, sir? May I end the
Yes,
session?
very much. I wish to thank my co-initiators, that is Mr. Monoranjan Bera. We could not get much of him, and Mr. Pathak. So thanks to them also for, and of course to all the participants.
They have added much color to your lecture, sir. They have added much color to your lecture.
Okay, okay. And I hope we'll be getting more of Mr. Bera tomorrow when we have this discussion in Bangla.
Okay, so with a big thank, I am going to now end the session. Thank you all. Thanks everybody. So thank you, and I am putting the session off.
Thank you.